good evening, or afternoon, or morning, or what have I missed out? Lunch. Good night. I know it's when you finish, isn't it? Hi. Right. Yesterday we went through chapter 6, which was rank n types, and we kind of got to we got around, we were sort of questioning what was happening with, I think we were questioning what was happening with the for all was a major thing, how this was kind of like being passed, why it's one place and then not the other. And then it turns out it's something to do with existential, what is it called? Existential type, not type, so it's existential something else. Where is it? Here. Existential quantification, and to do with for all. And then it basically says here, and I started reading this. I'll link it actually, in case for further reading. I'll put it in here. And it says there's two. There's a universally quantified and an extensionally quantified. And if we remember yesterday, which might not, was it yesterday or the day before? Maybe it was the day before. I can't remember. It was to do with where this R's been implemented, ultimately. And we did loads of examples. But I think that this chapter is going to go a little bit more in depth with that. I didn't actually realise. Existential types and eliminators. I'm not sure. I've not done it. So let's find out. Module 7. Okay, existential types and eliminators. Closely related to rank n types. Yeah, so they're kind of like... actually, what I'll do is, instead of making this massive, let's make it sort of yay big. Yeah, because it does go on. Here it has like a whole section about rank n types. But yeah. Anyway, let's do that. Okay. Types. So rank n types are the I've been saying the word loads of times now. It's just gone out. Existential. Existential types. These are types with a sort of identity problem. The type system has forgotten what they are. Although it sounds strange at first, existential are in fact very useful. For the time being, we'll look at a simple example, the any type. Cool, let's type that in then. Data any equals for all a, put like that, any little a. Okay, so we've got that. Any is capable of storing a value of any type. So that's the, I guess here's where the value of any type can be. That'd be my guess. And in doing so, forgets what type it has. It's a bit like me, that. I can hold information in my head and I forget what it is. I can relate to any. The type constructor doesn't have any type variables, and so it can't remember anything. Okay, because it doesn't have like that, it can't remember anything. Oh no, that says a constructor. That's the other side. Does it say the type? The type constructor doesn't have any type variables. Oh, okay. And so, because that's the constructor on the right-hand side. Okay. So it can't remember anything. There's nowhere for it to store that information. In order to introduce a type variable for any to be polymorphic over, just to be polymorphic over something? Okay. We can use the same for all A as when working with rank n types. This A type exists only within the context of the any data constructor. It is existential. What? I've been saying it like all day and reading it all day, and for some reason, as soon as I come on a stream, I struggle to say it. The syntax for this, for defining existential types in data, I'm just going to like mumble it a little bit and get away with it. Existential types in data constructor is heavy-handed. Okay, so having it like that is a bit heavy-handed, it's saying. Gadgets provide a more idiomatic syntax for this construction. Okay, so let's make another one. We'll comment this one out, and then we'll make another one, because obviously they're going to have the same name, so we don't want that. So it's going to complain to us, but we'll hopefully Haskell language server. Okay, well, first and foremost, it shouldn't be happy with that. So let's do this. Come on, Haskell language server. Be unhappy. There we go. Yes. Illegal, algebraic. Yes, that's fine. You should recommend us. Yes, allow. So if we go up here, there we go. Add, get it. Sweet. I did all that just so I didn't have to type it out. Yeah, because this, you can't create gadgets like this. If we remember gadgets, they come with the data, whatever, and then a where. And that's from that where you know that this is going to be a gadget. Because normally you'd have, like, well, if you look at the one before, it'd be data, any, and then it's usually equal. But a gadget has a where. And then you know from then on. And then you just, you know, if you have more, you can kind of go this. Oh, you can go this sort of way and add blah, blah, blah. Okay. So that's cool. We use any to define a list with values of any types. Okay. At first blush, it's that first blush, you know, when you go like, oh, I'm blushing. This sounds, maybe it's at first blush. Is that? Stop analysing. This sounds like the H list we constructed in chapter 5. Let's have a look at that. H list we constructed in chapter 5. Here's chapter 5. Where's H list? Oops, don't do that. H list. Where was it? There we go. So where was it? Is it referring to, where's the original though? There it is. Yeah, okay. So if we look at that, it's saying we can use any to define a list with values of any types. At first blush, this sounds like the H list we constructed in chapter 5. Okay, yeah. However, the usefulness of any list is limited due to the fact that its values can never be recovered. So if we do the type of, let's do that actually, let's bring that down. Let's Control C, Control R. Here we go. I'll wait for that. I'm just loading up the REPL. And then in here, we'll just ignore that stuff. Yep. It's just warning us about things not being used, imports. So then, oh, hold on. I need to load. I've done it from the wrong place. No, that's fine. It doesn't matter. I can open it from wherever. I was just about to say just speaking to myself, but technically I'm always speaking to myself. If you think about it. So chapter, it's not too bad. It's not too bad, I think. Cool. So the answer is here, because if we remember, that's just jargon about stuff that comes up in that REPL. But if you go in the normal REPL, it doesn't. So any 5, any true, any hello is the type of list of any. Okay, so we've got that. That's cool, which is exactly what we've got here. Okay. Existential types can be eliminated, consumed via... I'm sidetracking again. Stick to the business. Okay, existential types can be eliminated, consumed. Okay, eliminated or consumed via continuation passing. An eliminator is a rank 2 function. So we went into ranks in the last chapter. A quick update of ranks is kind of like what's the explanation of a rank? Essential types. Okay, it hasn't. I've not read on too early. Yes, it's a depth of the polymorphism. Thanks, Tintin Thong. I'm glad you're here. And an example of that, it's okay, I'm still going back to where I was going. If we look at int for all a, that's a rank 1. And then this is a rank 2, because if we look, there's 2 polymorphisms. And then this would be a rank 3. So you look at the innermost for all, and then count the arrows. 1, 2, 3. So that's a rank 3. Okay. And it's to do with also like the how deep is a polymorphism. Which, if that doesn't make sense, you might have to look at chapter 6 to get an idea. Because I kind of struggled over that. Well, I didn't struggle, but I didn't work it out that it was as simple as, oh, find the innermost for all, and then count the number of arrows, and that gives you the rank of it. Which still feels a little bit funny. I think that's right, but yeah, I didn't check to see if it was right. Hello? No. Like that? Like that? Sorry, I'm just jumping around. Cool. Okay, keep going. Rank 2 function, which takes an existential type and a continuation that can produce a value regardless of what it gets. So let's read that again. Existential types can be eliminated via continuation passing. An eliminator is a rank 2 function which takes an existential type and a continuation that can produce a value regardless of what it gets. Okay. Elimination occurs when our existential type is fed into a rank 2 function. To clarify, the eliminator for any is elim any. Okay, let's type it out because I think the code will probably make more sense, hopefully. Especially when you type like that. So we've got a function of for all a to r, and then we've got an any, and then we're going to return an r. So if we remember, when we do the for all inside, like, so when we do a for all here, that's, hold on, I've got to remember the terms because they're here. Where are they? So that's universally quantified when it's on the left, because it's you set it, the caller sets it, but then when you have it on here, so you're saying that function, the for all a of that function, is going to be set from within this function, then that's extensionally quantified. I learned something new today. So elim. I think that's right, isn't it? Yes, so f is our function, any a is our any, and that's just fa. Oh, okay. Right, so it just gets rid, it essentially just gets rid, yeah, elim any just literally gets rid of any. That's all it's doing, it's just going, see your any, I want that a now, thank you. And then I'm going to call my function against it. And then from that point, this is a clever bit. Whatever that function happens to be, we're setting it from here, whatever this type happens to be. So we've got a function from a to r, and at the moment that's still polymorphic, as in it can be any a, which can be any type. But at this point, whatever we pass as an a, it's still any type, but it'll be set from this point here. Okay, so that's cool. We get that. We get it. Or at least I do. If you don't get it, ask, and then we'll try and see where you're struggling. Because I definitely question myself a lot. Okay, so to clarify, pay attention to where the A and the R types are quantified. The A and the R. Oh, hold on. Yeah, there's an R there and there's an R there. Okay, so that's the return. Yeah, that's fine, because the A is quantified there, and then I guess the R is wherever that's returned, and then that's the same one. So it's all within this. Is that what it's saying? Pay attention to where the R types are quantified. The caller of elim any gets to decide the result of R. Oh, okay. Right, so it's the R's quantified by this caller, but the A is quantified by us inside elim any, I'd assume. But the A is determined by the type inside the any. Yes. So the A is determined by whatever we've passed here. That makes sense. This is the bit that's like a little bit freaky. We're basically able to control where we're quantifying this for all A. So you can imagine the F has that. So the F would be something like this. So look, we can literally just rip that. So my F would literally not be like that at all. Okay. And that, you know, let's just ignore what it means. Oh, why? Oh, okay. Yes, that makes sense. So we haven't got. So it was complaining, and then it doesn't have any. So for all, I guess in this scenario, we'd have to give it something like that. Okay, that's cool. I think. Yeah. Yeah. So then here, we'd be able to set what the R is. But then there, oh, and at this point, actually, oh, no, it would be like that. And then, but what we're saying is because that's as part of our, instead of it actually being on the left like it is here, we're able to set this A from within here and not from within here. That's kind of what it means. But then I'm not sure actually if this is correct. But we haven't told what an R is. Yeah, okay. But ultimately, yes, we could just do like this. If we wanted. There we go. Yeah, so now we set our R in myF. Because myF is anything that's A to R. And then we're saying the R is the int. There we go, sorry. I've got it now. So we're able to set it from this. We're able to set the R from here. But then here we're able to set the A from within here. Like that. So we've ultimately got a function that kind of like just gets rid of the any and applies whatever, you know, because we could have multiples of these ultimately. That's what it's getting at. We can use that function with multiple types. Hold on, so it'd be like myF tick. That's the idea. And then when we, so if we were to test it, so if we were to test elim, any, we'll go my f tick, and then it'd be any a, wouldn't it? So then it'd be any, what would our a be? Oh, well, I can be whatever we want. So let's just make it 5. Let's reload that, see if it works. I'm holding my breath. Yeah, it works. Cool, and then if we copy that, we've got a poop too. So we always need a poop. And then that could be, so then we know that whatever this function does, it will return an int. So that, sorry, for that one we'll return a bool. Let's put it the other way around so that it's not too, I know I've named them, but whatever. So that one will return a bool, and we can even, we'll pass it the same int. So we know this function does a to, sorry, we now know that that gets passed along to that goes into here, that sets that to int to bool, which is then int to bool, so then it's any to bool. So we're basically, so we've got the ability, so look, we've used the int over that, but we can set what the int is, sorry, what the any is when we pass it along. I think that makes sense. Yes. I lost my trail of thought there, I'll be honest. Yes, it's just flexibility, isn't it? We're able to do pretty clever things with keeping that polymorphic until we pass it in. And then this function is even more so, because then we can dictate it by these types, dictate what our R is going to be. And then I guess inside of here, I guess you could, yeah, how do you handle like what, because this says this takes an A to an int, but then how are you going to handle, I guess at the moment we're saying int and int, but what if that is like that? It doesn't, it compiles, but technically you've got to make sure that your function can handle these different types coming in. So I don't know how to do that, but maybe it explains. Okay, so let's uncomment, or not uncomment, we'll comment our little experimentation of poop. I don't use foo or bar, I use poop. I don't know why. So pay attention to where the R quantified and call eliminate gets to decide the result of R, but A is determined by the type inside of the any. Yep. Are functions of type for all A to R interesting? Why or why not? Are they interesting? Oh, so that's kind of like, but that didn't work, did it, when we did that A to R? So this, oh yeah, I guess they are interesting in the fact that we're setting what the R is from here. That'd probably be why it's interesting. Would be my guess. I don't know how we can check that. I can't. We could. No, we'll keep going. We'll check once we get another. We'll note to self. Once we double check what this is, then we'll check out if my beliefs. I say are, but it's just me on my own, isn't it? This approach of existentialization types and later eliminating them is more useful than it seems. As the next step, consider what happens when we pack. Hey, SuPP, they are not interesting because you can't actually do anything with the input value. Oh, I went for interesting. Oh, I found them interesting. I like uninteresting things though, maybe. So they're not interesting because you can't actually do anything with the input value of the A. So they're not interesting because you can't do anything with the A. Oh yeah, because it has to. So for it to work, that's what I was struggling with. That for it to work, it has to ignore the A then, I guess, and return an int. Is that what you're saying? I think that's what you're saying. Because it exactly cool. I'm glad. Thanks for the email. Gil Christian's live as well. I've like Oh, I shouldn't be advertising. Don't go to Gil Christian. Stay here. So, can you try my f with x to 1? Oh, like const true. Oh, that's the same thing. That's the same thing. I can try that though. Let's do it. So my f, and that's going to equal. Hold on. Should we do the type first as well? You know what? Let's do some of this. Oh, some of that. And then you want to give it like a lambda x and return 1. Yeah, seems happy. So that's exactly what it's doing, isn't it? I'm with you now. I'm going to refresh it in case I don't trust it. But yeah, const true. Yeah, that's fine. So yeah, that's totally happy. You can't. So yeah, that's what I thought. You can't technically. You can't ever do anything to guarantee, you know, that what the A is going to be. Otherwise, it wouldn't stay an A. Cool. Okay. That makes sense. Actually, what happens when you? What is the type of const true? Yeah, so it's beatable. Okay, that makes sense. Yeah, so whatever you do, const true. It's always going to return true, isn't it? Yep. So we're just ignoring that value. Ignoring that. Oh, nice. Okay, that clears it up a little bit. Like that. That's cool. Thanks for the advice. See, that's kind of like why it's fun streaming when you get help. But it's also fun teaching when it's stuff you actually know. It's not too bad then. Okay, consider. So the answer is it's not interesting at all. No, I found it interesting, but it's not, because the A has to be ignored. You can't do anything with it. So any just yeah, you pass it that 5, and it's like you might as well just not pass it, because I'm not going to do anything with it. Thank you. Yep. Okay, so we read that bit, but I'll read it again. This approach of existentialization types and later eliminating them is more useful than it seems. As the next step, consider what happens when we pack a type class dictionary along with our existentialized data. Whoa, let's do that then. Data has show? Yeah, where so So where has show, and that's going to be of the type show. Oh, sorry. We're going to constrain show t to has show. There we go. Okay, so we've created that type, or sorry, that gadget. What's going on here? So let's have a look. So we've constrained the t, so we know the t's got to be of, you got to be able to show it, and has show is that. So you give it a t, I'm going to return you a hash show. Okay. So the definition of hash show is remarkably similar to the gadget definition of any. So if we look, yes, apart from this constraint, probably as we're going to say. With the addition of the show t constraint. Yeah. Oh, did you? Sweet. Is it quite useful? Nice. Oh, well, that's good. It was in there. Good. I haven't. Well, technically I'm using it now. I think I've probably used a lot of this. You as well. Everyone's killing it with Existential Types. Ah, right. Am I going to be killing it then after I've done it? I was going to say is I feel like I've probably used it more than I think I have. But saying that, I've not created functions with that in, I don't think. Not as from now. But that's good. Well done. Nice. I like it. And now let's think, is that... say you had like a junior. I guess you could explain it without too much in depth by just its use. You know, you could sort of explain it by, well, ignoring the for any, but you know, the fact that where the for all sits is where you're instantiating that A. That wouldn't be too bad to explain to someone that just, you know, knows a little bit of Haskell but needs to use a code base. You could probably get away with that. Yeah, nice. Anyway, so it's got a constraint. This constraint requires a show instance whenever constructing the hash show. Yep, and Haskell will remember this. Well, I'm glad it remembers it. Haskell remembers everything. Because a show instance was required to build hash show. Whenever whatever type is inside of hash show must have a show instance. So that's cool. So at least you got like a type. It's almost, yeah, so it's like a type level type. So it's just making sure you've got a show. Remarkably, Haskell is smart enough to realize this and allow us to call show on whatever type exists inside. Oh, nice. We can use this fact to write a show instance for hash show. Okay, so we can do an instance of show, hash show, where, oops. And it's obviously going to do it on show. And then we're going to have hash show, and we've got an S. And that would equal, whoops, hash show space show S. Yeah, which makes sense. So we know that this S is going to work with that show ultimately because it's constraint to show, which makes so that, yeah, I think that makes sense. I'm happy with that. Let's move this down a little bit. Okay, exercise. Here we go. What happens to the instance if you remove the show t constraint from hash show? Well, it's going to fail because it's not going to know what the S is. When I refresh it. Hopefully. You better fail. Yeah, there we go. Cool. So right here, it doesn't know. That S could literally be anything. And show needs to have a show constraint. You know, that needs to have a show instance to be able to... The S, sorry, needs to have a show instance. So we can see, look, no instance for show t arising from the use of show. Yeah, which is there. That's why it's referring to a t, because we've named... Oh, does it change the name if we were to, like, call it P? So look. This is just out of interest. Yeah, sweet. That's interesting, isn't it? Could use that as part of the error messages. Anyway, let's go back. Okay, so that's why. and then we'd need to do show t like that. Now it's happy. Yeah, okay, so that was an alright exercise, wasn't it? It wasn't too bad. More generally, we're able to write an eliminator for hash show which knows we have a show dictionary in scope. Okay, so now we're doing like an elim any, but we're doing an elim hash show. Oops, we'll do capital oh. Whoa. Has show. So this is going to be, oh, here we go. So now we're going to do some for all a, whoops, show a, and a to r. Okay. Yeah, you get to see a lot of this, don't we? This function. It's like a recurring theme. Whoops, I should have done a bit of this. Let's just do that. Okay. And that we pass it a hash show, and we return an r, and then a lim hash show. Yeah, there we go. And that should be an f, a hash show a, and we're doing exactly the same thing. Equals f. Whoa. So it's happy there. I mean, we could have probably put that on one line, but it'll be fine here. Okay. So we've done that. So write the show instance for hash show in the terms of elim hash show. So hold on. Write the show instance for hash show in the terms of elim hash show. So what using? Oh, first and foremost, don't know why that's compiling, because it's clearly different names. Yeah, now you're the same. Yeah, this is what I mean. It just refresh it, it'll be fine. It should pick it up on the fly, but I don't know. Okay, so it write the show instance of hash show in terms of, okay, so we can grab this, and we need to be able to elim hash show to use it inside of here. So we need to rewrite this. I'll do it down here. Obviously it's going to get an error, but if I comment it out, where am I? Book, there. So I guess we need to pass a function of show a to r, which is what show a to, yeah, that's our function, and then our hash show. So we could just leave that as, we can make that s, and then here we can have, I guess it'd be something like this. Okay, I think that's correct. That's what we're getting to. Let's have a look. Compile. Be right. Yeah! I think that's what it was after, wasn't it? Cool. So that makes sense. Yeah, so we're using, again, yeah, well, we already know that that's, yeah, so we want a for all a with a constraint of show a to r, which is exactly what show is. A constraint of show a, well, the r is a string, so that's fine. And then you pass it a hash show, which we do, because we don't deconstruct it there. And then when it goes in, it literally passes show to s. And because we know that this value is also a show constraint, it's happy to do the show s. Yeah, cool. Okay, I think that's not too bad. Dynamic types. I feel like I speak too soon when I say things like that, like I'm jinxing myself, and this is probably where I've jinxed myself. This pattern is packing a dictionary along with existential types becomes more interesting with other type classes. The typable class provides type information at runtime and allows for dynamic casting. Oh, okay. I don't really fully understand what that's saying, but hopefully we'll get to see. The typable class provides type information at runtime and allows for dynamic casting via cast. So it's a cast. Let's take this and bring it in here for a minute. I mean, I'm sure we're going to go over it, but let's just do that anyway. So cast is a typable, well, it's like, what is it? Dynamic means at runtime. Oh, okay. Yep. Oh, I thought it meant something else. Maybe B. Thanks, UPB. Yeah. So cast. Oh, look at this. So it's got typable. Oh, it's going to be typable A, typable B. Because that seems a bit weird. Okay. And it's saying allows for dynamic casting. So at runtime casting. Well, casting is exactly the same way as when you're casting for an audition, I guess. So you're casting a type. Let's find out. We can extensionalize typable types in order to turn Haskell into a dynamically typed language. Oh, okay. So using this approach, we can write Python-style functions that play fast and loose with their types. As an illustration, the plus operator in Python plays double duty by concatenating string and adding numbers. Yeah, here we go. Right, this is cool. Oh, dynamic. Oh, hold on. I'm rereading what you wrote. It's the same thing. Okay, this is interesting. And we can implement the same function in Haskell with dynamic. So given the data type and its eliminator. Let's do it. I want to do this. Definitely. I mean, I don't know. Yeah, let's not. Don't make any sarky comments, Vince. Just get on with it. I'm gonna say it anyway. I was gonna say, well, why do you want to make it less flexible, huh? But that's not gonna help anyone. So T to dynamic. Okay. So we've got our gadget of dynamic. That's cool. And we've constrained it to typable. Actually, isn't it? Shouldn't it import that? Yeah. Well, woo. Technically, let me think. So I'm in advance and you're behind. So we thought about it at the same time. Let's say. Yeah, I was thinking that exact thing. Which import to use for typable? Well, just press some random keys like this. Reload that. Superb is coming with the killer. But I was going to let the Haskell language server do it for me. But no, it's just happy. No, it's not. Thank you. So you're saying from data typable. Cool. Data. Oh, that's a bit weird. Data typable. There it is. Cool. So we're going to import. Oh, another. Except it did a bit weird there. Got a bit confused. Or data. We're going to go with typable because I think I've seen it in typable sugar before. We'll get rid of that. Yeah. No, go to the bottom. Cool. Or data. Now we want to, so we've done that, and then we want to elim dynamic. Actually, I'm interested. What is the typable? Is a K to constraint. Oh. So the class typable allows a concrete representation of a type to be calculated. Ah. Okay. Interesting. We'll see how it works then. Elim dynamic. Is that what it's called? Yeah. And then we're gonna let's go down a bit. Why aren't you? Hello. What's wrong with you? Won't go down then. Guess it got to the bottom of the page and it's not going to extend. Oh, I should have pressed enter a bunch of times. For all A. Keep pressing wrong keys. Typable. So for all A, constraint of typable A. I can't believe this stuff is starting to make sense. You know, it doesn't feel like it should. And we've got this little jobby again, except this time we're constraining it to typeable A rather than show A that we had above. Spot that, spot that. And then we're going to go dynamic. So we want to give it a dynamic. Okay, that's fair enough. And then we're going to return an R. And I mean, this is going to be fairly obvious what's going to happen here without even looking. Elim dynamic. It's going to be an F and then a dynamic A, and that's obviously surely going to be FA. Yep. Okay, that's happy with that. So we can implement from dynamic, which attempts to cast a dynamic to an A. Ooh, hello, this is a new business. So from dynamic, whoops, I was waiting for like for it to give me an autocomplete on the function I'd not written. Well done, Vince. A, so we got a constraint of typeable A, and we're going to take a dynamic. Okay, oh, and we return a maybe A. That's interesting. Cool. We use this cast. Cast. We have to look what? We're going to have to look at it. Oh, we see the lim dynamic. Okay. And then our function we're going to pass a lim dynamic from an A to R is cast. Oh, that comes from data data. So maybe we should bring the other one from data data. Oh no, we can add it to, so it's in typeable as well. Okay, so let's have a look at what it says. Cast. It's the same. The type save cast operation. Is these clickable yet? Oh no, they're not. They used to be. Source. Technically they should be. Maybe I didn't allow my docs to be built. Okay, well that's fine though. So this is a little bit. So it mentions cast up here. Allows dynamic casting via cast. So let's have a look. It does typeable. So the constraints are typeable A, typeable B. And we take an A and return a maybe B. Oh, okay. And then from in here, we're passing that A, which we know is of typeable. Okay, so that's gonna be good. It's gonna pass in there, and then it's gonna return. Cast returns a maybe a B. I'd like to know how cast looks like on the inside. On the inside, you know, its implementation. If we can see it. Whoa, hello. So we want it from data typeable. Here it is. Let's have a little look. Ooh, there it is. Source. Yes, we're going to look at source. Cast. Whoa, hello. So just, wow. Something. Oh, you can do that? Look at this madness. Okay, maybe it wasn't a good idea to look inside. So if something... I don't understand the bind. Is what? I assume this has a different operation. It's not like a left bind, is it? Because that'd be potentially weird. Because I mean, here should... We're saying if it's bool or not. So what's that? That's equality. Whoa, how did you get to the type signature for a Hugel web? I think it's just... No, I just think it's on it. It looks like it. I think if you hover long enough... Or did I went through it via hackage? Yeah, I did. And then when you hover over it, you get to see what these types are. So that looks like, I assume that's something to do with equality, isn't it? A to B. But then it's a little bit confusing why there's a... So X, it's saying X... Oh, no, hold on. It's like a guard, isn't it? So we've got X, and X is a value A. And then where's X used in here? It's not at all. So where's TA's type rep? Oh, okay. Oh, what's this? SUPP. Read pattern. So case to pattern equals body, like case of pattern to body. So it's oh, can't read that. So case to pattern. Oh, it's literally like a. So it's like a polymorphism of case to pattern, or yeah. Is equal to body, like case of pattern to body. It's pattern matching in guards. Yeah. Oh. Interesting. Yeah, so you... Wow, okay. And the TAs come from type rep A. Is of the type rep A. Like, is it a function? No, they're down here. Oh, I didn't even see them. Right. Okay. Yeah, so it's all to do with type representation. And what does this take? Wow. Oh, it's literally, so it is, because we're getting, so if we look at the return type of this, it's maybe something. So we're binding out. Look at that type though. It's not looking at what this means quite yet. Yes, which makes sense then, because that's why there tells us it's an A squiggly B. And if we look at the return type, it's maybe of A colon squiggly colon B. And we get it out of maybe, put it into here, and then just of that. And if it is that, then return just of X. Otherwise, return nothing. Okay, it's not... Well, we kind of worked our way through it. It's not too bad if you ignore what this means. You're there, aren't you? So does that act like... I guess that acts... Yeah, so it does act like a left binder, I assume. But then you're able to give it... So it's to be able to give it that... Yeah. But it's pattern matching against just. So I assume for... Oh, yeah, that's a bit... It's still a little bit... So where's the A? The A's coming from there. Oh, but we're still using... Okay. Okay, let's... Come on. This is potentially going above and beyond. Let's go back to here for a minute. So we kind of know that this is doing a check if our type... What is it doing? Yeah, so if we look at cast, if it's... Is it an equality check on the type? Oh, hold on. I should read your thing. If it succeeds, you go to the body. Okay. Then, so look, so then we're passing that along, so that's our F. But then oh, okay, yeah, and that expects an A, which should be our A. So this function, our R. Oh, it's an old message. Okay. Yeah, that's that delay thing. Sorry. And if I don't see it, then I go ahead like for a good minute or something, and then I take it like you meant it from right now. That's the other thing. That's why I thought there'd be... See, if there was a time, because I get to see this, and if there was like, because I thought this clock was a time, and then it tell me what time something had happened, and I've clicked it, and it's actually it stops people from being able to type for 600 seconds. So I can't tell when a message is coming, unfortunately. Okay, so we're doing type safe cast operation. Interesting. Let's keep going. I think whoa, a helper function will assist in the implementation. Well, I hope so. Look at the state of that type. Lift TD. Lift D2, sorry. What am I talking about? Should we type it out like okay, so so now right, I'm going to keep going over it and then I will remember which one's which. So universal, existential. Existential. So now we're doing like a universal for all. Yes, these are universal for all. A, B, R. Okay. And they're going to relate to, if I press the right one, typeable A. Let's do that. Let's do that. What am I doing? Oh, comma. Wow. Typeable. I spelled. No, I did spell it right. Where you go? Typeable B and then typeable R. Sorry, I got totally distracted. My brain just left. So, whatever. Exactly the same. And then that's the constraint. Cool, we got that. And we take a dynamic. Hello, a dynamic. And another dynamic. I keep doing that. Okay, so we take one dynamic, two dynamics, a function of A, B that returns us an R, and then the final one, what we return is a maybe dynamic, which basically is going to be from dynamic, elim dynamic together, I'd assume. No, because it's taking two dynamics. Okay, let's keep going. Maybe, oh, maybe dynamic. Okay. But, so we're lifting dynamic 2. Oh, okay, so here we're only lifting dynamic 1, aren't we? So this, this is dynamic, maybe dynamic A, typeable A. So I think so, yes. So that would be dynamic 1, and this is going to be D1, D2, and that's going to equal, yeah, we want an F map. Oh, okay. I wasn't expecting that, to be honest. Dynamic and F. Whoa. Sometimes when it's written like this, it can be confusing to work out where things come from. Oh, so we've got this. Where's D2? Okay. Oh, so we're doing D1. Okay, so we're doing like an apply. Okay, that makes sense, I think. I'm going to have to put them onto new lines, but let's just quickly. And then from dynamic, at B is going to have to be at B. Wow. Okay. So who said they lost their minds around here? I think I can relate. So F map dynamic. Let's F map. Let's think. I'm going to put some of these in to work out where things should go. I don't. This is slightly confusing. So I guess it's going into F, but it can't. Difficult. You know, because if we look at the type of F map, it's going to take an A to B, the function A to B, FA and FB. Okay. So what's our function A to B? And is that, oh, is because we're passing it along? So this is, you're not going to show us a type. Oh, I guess I have to do things like this for things to show types. What's A and B? That, I think, is when we want to, when we're referring to this A and that B. I think that's what it's mean. Oh, type application extension. No, don't include that. Oh my god. Now I've done it. Oh no, it wants it, Hold on. First and foremost, get rid of these lines. I think that's what it is. We'll read it. Okay, now it's happy. What's A? Not in scope. Well, I don't know. Yeah, I thought it came from... We don't have an A and B anywhere else. D1, F. Oh, first... Oh, I'm missing an F also, so that's going to... Okay, so it's happy now, I think. Which would make sense. I thought it would have got an error on the F, not on the A, which was a bit weird. No, we still not got at A. What is this voodoo? Oh, scope type. Oh, yeah. Yeah, it's not on. Sorry. I see what you're saying now. Yeah. That is definitely what we want to do. Why doesn't it just write it all out for me? Right, now it's happy, which is fine. Yeah, you're both right, which is cool. So we've done scope type variables before, I think. And the idea that it grabs those. Yes. Oh, hold on. So A and B are determined by the caller. Aha, so this and this is determined by the caller of lift-d2. Yeah, so that's a... oh, come on. It's going to stick in. Why is it not sticking in? A universally quantified. Yes, because that's the caller is going to determine. So it's universally quantified. And then from dynamic, there it is. It takes a dynamic. So does that mean we're quantifying that? Yeah, that's what it means. The first type annotation for dynamic is A. Yes. So we're doing at A to quantify what the A is going to be, which is going to be the A that's by the caller, which is determined by whoever uses lift D2. So they're going to be able to say, yeah, the A is going to be that. You're passing that A along. It's beautiful or horrendous. It's yeah. Okay. How'd you get away through? No, but it is. I get it. Oh, so it's like functions. It's like your type level stuff just becomes functions, doesn't it? So you got like a. So that's why the complexity sort of doubles. You've got like a function of a type functions essentially. Type level programming. So you roll. Which way did you go? Up and down or left and right? I feel like I need to go forwards, like roly polies over the keyboard. Sorry, Kyle Capitals put. I rolled my face over the keyboard until it worked. Yeah. Oh, well, I guess you can read it because I record the comments, don't I? Never mind. So, I'm still a bit confused by this. So, what does this... That should return. So, and maybe dynamic. Is it F mapping twice to get the value out? I guess yeah, I kind of wanted to see it all together, which is a bit of a shame. So I assume we're returning the result of that. Let's see. No, okay, so it's not that way. Yeah, it's why sometimes when it's red like this. Okay, so that's fine. Scope type variables. Yeah, that's the right. Yeah. It is. You are right. And then this one, I'm just trying to work out what's actually going on. F, that's fine, because... hold on. Is that right? Well, yes, because F is... Because if you remember... F, A, B, R. And now R is put into dynamic. And then we F map that... Okay, so it's going to have to be... Is it? No, it's still wrong. You got typo. Oh. How did you? I'm trying to work out... Well, if I follow along, we can see that F is going to return A, B to R. So A, B... So we're going to compose the R into dynamic. That's fine. And we're going to F map. Oh, whew. I'm trying to split up where our FA is and where our A to B is. Which one's our FA? That's what I'm trying to do, but I don't think this is right at all. Of course it's not, no. Sometimes the beauty of Haskell is just too beautiful. Well, what's the... our dynamic is A to B, so that's our A. Yeah, that's what I thought. I tried to put something here, but then that's where, like, it says no. Oh, is it because... Hold on, have I done... Yes. But no, that's going to be wrong. Look at it. Look at it. That can't be right. It then needs, like, the F, doesn't it? It's like, what the hell? It's definitely a Should we not try to work it out? And just deal with it? Just deal with it. No, I mean, we should at least a little bit try work it out. So we know that F map, because we're not returning a function of any sorts, it's definitely... Oh, hold on though. It's a maybe of something. But we know that whatever goes into A to B, and it's an FB. So our F is going to be maybe. Okay, so we're down with that. And I guess when we got F map, dynamic, if we look at dynamic, our dynamic text value, so that to dynamic. Okay, what I'll do is just swiftly move on. Though I'm still confused. Oh, hold on. Is it like this? Yep, okay, we're getting closer. Try to write it explicitly with do notation. Might make it clearer. Yeah. Oh. Hi, by the way. I don't know how to say it. 2TBWF. I've been watching some of your streams and getting confused. I think it's a rabbit hole. It is a rabbit hole, isn't it? Should I follow it? Didn't do it. I feel like it's calling me. It's calling me. So I guess that with do notations. Do notation. Do. How can we get the do notation? So the equivalent of, we're basically using that. Okay. We'll call that, whoops. Let's just comment some stuff out. I think I'm going the right way. D2. I think I am. I don't think I am at all. I think I'm going the wrong way. But I'm going to keep going. Keep going. If you're going to go the wrong way, just go all the way the wrong way. Rather than not. No, I'm definitely going the wrong way. We've got F. Okay. So we can do this. Dynamic. Which is F of D1, D2. Hello. That returns poop, would be my guess. And then let's have a look what we want to return. This isn't going to work. Of course it's not. Yeah, you're right. They're saying that. Okay, we're not too far off though. Okay, so I guess I don't want, I could still let's have a look. So it goes F. Okay, so look what this. I guess the issue is with this dynamic part. But I thought dynamic could take. Hey, how's it going? You're right, Leo. I'm still live. I'm potentially slightly dying inside though. Okay, let's do something like this. See what happens now. Okay. So it's saying found a hole B. We need to, where's that? Come on, types. Give some help. Help us along. Type checker. Wicked. So yeah, well, let's. Oh, I like it. Look at this. You can't friggin' scroll up. Typeable A. Oh, so it's. What's the type of this? Actually, I could just hover and it'll tell us. It's a B. So yeah, I can pass it. You can do LSP describe thing at point. Oh, can I? To get a type hole. To get the type of a type hole. Oh, well, I guess it. Yeah, it is. I found it there, so it's B. I was just trying to find what this one was, which is B. So I guess, you know, so that's going to be. So I was on the right lane. D1, D2, and then here. I don't know if I want to. So I need an R to maybe any. What? So I don't think I want a left bind. Wow, look at this. Ding Ting Tong's coming out with the heavy hitters here. Look at these heavy hitters. I've got a feeling that this F is correct. But I've definitely gotten to this stage. Oh, you put in a parenthesis, yes. Yeah, the code format. It's the worst, isn't it? I've got used to it though. I'm gonna write code in the Twitch chat from now on, just to better my life. Okay, so ultimately, let's just do. This is bad, but we'll Well, it's not bad, but at least then we know. Still not happy. Happy. Poop. What does it want to return then? Type hole, maybe dynamic. And what's the type of that? Just dynamic. And I guess the content of it would be what we want. No, you can't left bind on it. Okay, go back. Like that. So we've got poop. And then from here. So we still have to do fmap. We have a dynamic and we need a mate. Do we? A dynamic. What? So you can't just return adjust. What? Adjust poop. That doesn't feel right. If only there was a function that had a type A to FA. Pure. Just. Oh yeah. If only there was. Now. Okay, I assume that's correct. Which one's more readable? I'd say the top one. For me, anyway. I think. I like your comment. If only there was a function that had a type A to FA. If only. Or, I mean, you can do return as well. It might help if D1 were bound to D1. So I don't want to backseat code too much. No, backseat code away. It'd help. Might help if D1 were bound to D1. We're bound to D1. If D1 was bound to D1. Eh? You've written the same thing, haven't you? Oh. Oh. So if that was bound to that? The naming. Oh, okay, yeah. I've done them wrong. Oh yeah, yeah, I've done the wrong way around. I see what you mean. Yes. I'll just check in. God damn it. Be with it. This is what you mean, isn't it? Oh, now it's gone the wrong way. Why have you... Is it the other way around? Yeah, I was just checking, that was all. There we go. I think that's what you meant, isn't it? I'm just making sure that you're on check. Except that's still... No, that's right. Yeah. This will crash. Why would it crash? The type applications of F. I will escape this rabbit hole any minute now. Don't worry. But now you've thrown me. I think it won't. The compiler is clearly telling me that it's fine. Oh, we are saying D1 as a type B. Oh, sugary bollocks. Whatever that is. Okay, now it's better. Yeah, I was wondering why they're the wrong way around. Thanks. And I don't know what a sugary bollock is either. Just made that up. On the spot. Haskell got to me. Yes, that will crash at runtime, being that we're casting. We're like fishing. We're casting for a fish. And the fish we would have got would have been... So that's kind of like a problem, isn't it? So you got all the type safety, but then once you start creating your own crazy type programming, then there goes your safety. So essentially, which is what this part is about. We're making this. We're making Haskell dynamic, aren't we? Almost like dynamic types are hard. Almost. Well, this whole chapter was based on the fact that we're trying to make something like what did it say? I forgot what it was actually said. Yeah, we'll just do like a dynamic language, like Python. That's it, Python style. So to be able to use plus with either Gaffer, how's it going? Fishing in toxic water where all the fish already all the fish are already dead. Yeah. No, I don't think, come on, it's okay, well, I'm not looking at that one yet. I don't think it's that bad. I guess you'd have had to have realised that it's bad once you had it at runtime. But this sort of stuff is potentially more going to be used, I guess, when with making languages, maybe? I'd be my guess. Yeah, I'll name that something better though. Because we'll die. Yeah. Okay, that's not too bad. Now if we look at the 2, well, if we look at its previous implementation, I guess it takes a little bit of time to... Yeah, so when you read like this, you kind of understand that... Oh, okay. Yeah, I don't know. I prefer it this way, I think, like for sure. It makes a little bit more sense what's happening. But from here, it's kind of like the F map throws me quite a bit. I think that was the main issue. And what was your... Hold on. Because you gave it another thing, didn't you? Oh no, yours was different. Ting ting tong. Let's just go back to how I had it. And what you went for. I don't know if that'll work, you know. Did it work for you? I know you were just... Ah. Oh, sorry. You're having a conversation amongst yourself. Don't read that. Hey, everybody. Hey, buddy. Yeah. We want to test it. No, let's just move on, shall we? Oh, you wrote your first... Yeah, I was watching part of that, and then I got really scared, and then I left. But it looked cool. And you were just... I think the bit I watched is where you were doing the Agda. Oh, you're there as well. Guys, I've got some sly viewers that haven't said anything. You're slying in there. You're just waiting for a bad joke and then you'll pipe up. Okay, keep going. We'll keep going because, you know, I don't want to dwell on this too much like I have for the past 20 minutes. This function attempts to lift a regular strongly typed function into a function over dynamic types. Equality induction hurts everyone's brain. Yeah, I bet it bloody does. Brains are hurting. But we've come through to the other side. Let's read this again because I forgot what I was reading. You need to add you to the declarative streamer chat live notifications. Oh dear. Hold on, I think you did, didn't you? I think you have. I'm pretty sure. Hold on. I saved it somewhere. Oh, yeah, that's a lie. You don't see a notification for me? Oh, maybe you... No. I'm thinking of the other one where it just shows who's streaming right now. Is that what I'm thinking of? Isn't it that one? I'm like, you know, James Bond with English and all that. I'm just sneaky. I just come online when I want, how I want. With no schedule at all, so people don't join. Right. Come on. This is me amping myself. I'm like a what do you call it? Like a jock. I could have done American football. Look at it. I'm built for it, aren't I? Like a stick. I could have been the football. This function attempts to lift a regular strongly typed function into a function of dynamic types. It returns maybe dynamic, which is returned if the cast failed. Finally, we can present a Haskell version of Python's plus operator. Oh, hold on. Mine says go say hi to Barry. Bring facts. Oh. What would I like to say? What would I like it to say? I don't know. Don't give me the choice. I think you should just pick for me. Because it's going to be obscene. And I put people off enough as it is. So like, don't make it worse. Yeah, I think you've got definitely a better. Right, let's write this pi plus. The plus that can work over multiple types because we're dynamic. What I want to do though, I kind of want to show it. Where's dynamic? Where was it? Here it is. So let's just do a bit of that. I don't know what I'm doing here. What am I doing again? Oh yeah, okay. I just didn't want to type it out loads. There we go. and then I'm just going to delete the whole line. Cool, well done. Right, go to the bottom. Yeah, now we can see where dynamic is. I just wanted, it's good to look over the whole code sometimes. Dynamic to a dynamic. Okay, so this is the ability to pass it whatever type we want. But I'm assuming... Oh, okay, no, I'm not even assuming. So we've got A and B. Wow. Oh, so we can do a from maybe. Okay, so we got from maybe. I spelled it right, yeah. Hold on. So if we just do. Whoops. Actually, you can just do that. What are you not happy for? Be happy. Am I bringing in the wrong from maybe? Is that what you're complaining about? Or just from maybe? No, it doesn't expect free values. I just don't think it's importing the right one. It should just be 2. Yeah, I thought it's just 2. So, which means it's not bringing in the right one. Data, here we go, there it is. Derp. Right, okay, now we're happy. Okay, and our first one is going to be an error. Oh, nice. And it's going to be, except I'm probably going to have to import that as well. What is error? Bad types for our pi. Whoa. I was reluctant to look at my keyboard then, so I just kept going until I found it. No, it's happy. That's happy. A sum. Whoops. Whoa. Let's go like that. I mean, you should most definitely not be. Oh, I forgot to ask. Well, I did ask at the beginning, but now, where's it coming from? A sum. I forgot where a sum comes from. I spelled it right. No, I've just made up a random. Replace with import foldable. Yeah. Take foldable. Ah, thanks. Ting Tom. Yeah, is the stream skipping every second or so? What's wrong with you? Found hole. Yeah. Well. Oh, is this a sum? What does it expect? Oh, okay. Well, that's probably why. No, it's not. For all blah 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 blah. TFA. Okay. Just give it a list. Yeah. Oh, I guess I could just... Yeah, well, the list... I mean... yeah, I could just go like that. Okay, it's happy now. I've given it an empty list. Deal with it. So, we're going to do lift D2, this makes sense. At, okay, so we're giving lift D2. So if we look at lift D2, we're making the A a string and the B a string. This stuff is like cool. A and B. Okay. Yes. And then the operator we want is a plus plus. Cool. That's our first one. Which actually makes sense. We'll just go over one for now. So that makes sense, doesn't it? So we're passing, we're making the A. So because this was global. Come on. Why can't I just remember? Universal, global, universal. Because it's a universally quantified, that means that we can determine the A from here. And if we remember, because we're using which constraint was it? Is it scope type variable? Yeah, scope type variables. Yes, we're able to do that one to something that one, which is going to be there, and then the B is going to be string, and then we're not going to do that one, and then A and B is what passing on, which is dynamic, so that's fine. Dynamic. And then the third one's a function of A, B, and R, which is what plus plus. If we look at it, that's just well, A, B, and R, because it doesn't really matter if it's a list of something. So that's fine. Cool. So that's our first one. And then when it comes in, I guess it'll do. Oh yeah. So it grabs a dynamic. It grabs A out of the dynamic using the A, which should. So that'd be like string. Yes, so we know that that's got to be a string. So it returns at this point. I guess at that point that'd be string. And then we do the F, which should be our function. Yeah, getcha. And that'd be plus plus. So at this point, this would be. Whoops. Plus plus, like that. It'd do that business. And then we wrap it back up in dynamic. No, we don't. Yeah, we do. Yeah, so we put it in dynamic and then we return it. But our return is of maybe. So it's maybe a dynamic of string. But where was the magic? Oh, and then the magic is here in cast. Well, it's not the magic, but that's where the biz happens. It's the biz, baby. It's where it happens. Yeah. Okay. Does that make sense? I think that makes sense. I wasn't expecting it to make sense, I'll be honest. I thought it was going to make no sense. But it's made sense. Oh, you know when you're on a... I feel like stopping now. End on a high. That's what I've always told myself. Just end on a high. When you're doing well, just end. Especially when you say left. Hold on, this one's a little bit more... Oh my goodness, these two bad boys. Yes, that's the other one you can't do. The first two kind of make sense. But the second two, this is a wild one, isn't it? How's it going to deal with this? At string, at int. Okay. A, B. And then obviously here we're going to have to do a lambda of sorts. Because we're on a function that takes two inputs. So it's tr a and then int b. Yeah. How does it work it out? Oh, so it's literally just going to return. Okay, so the whole return is going to be string. Yeah. Which is what Python does, I guess? I don't know. I'm assuming. Well, both are. Yeah, both in implementation, it looks like. Because you can do a show of int b because we know it's going to be an int, so we're showing it. And that converts it to a string. And then that string plus that string. Oh no, that would return something a bit weird though, wouldn't it? Oh no. So it'd still be... it'd still be weird though. Because so if we were to pass it like hello and then 3, then it'd obviously return hello 3. Yeah, which is exactly. I know you can do that crap in crap. Sorry, Python and other dynamically typed languages users. I didn't mean it, but I kind of did. Yeah, you can do that stuff in those languages. So it's just the other way around. Except I'll probably get. I could have just copied that other function, couldn't I? So it'll be int und stir b, and it'll be show und plus plus stir b. Sweet, we've got them all. We've done it. Now let's test it. Okay, in order to easily play with it in GHCI, we need to enable that. Okay. Try this too, please. Yeah, no, don't you worry. I'll try what you're doing. Yeah? Okay. Oh, I like it. Yeah, go on then. Let's do it. Good thinking. I like it. Let's do a bool one. Except I've mistyped something with the L. Kift, bool, at bool, AB. I guess we can just do it like that. It seems to be compiling. Oh yeah. Oh yeah. Hopefully. Oh yeah, I wonder what will happen. I like it. Good thinking. So first and foremost, let's do that. It'll reload, that's fine. What we'll do is we'll find where it is. I think it's that one. Yeah, it is. Good find. Okay, so we're now in the REPL. We're going to reload it. It's going to ask us for a bunch of stuff. So we're going to do. Oh God, really? She knows. Set. X. What we want? Type applications. No. Type applications. We've set it. Got it. To get the right type out. And set the default numeric type to int. To construct a dynamic without type signature. Oh, okay. Didn't know you could do this. Happy. So from dynamic at int. So let's have a look. From dynamic. Here we go. Oh, so we're calling it this way. Okay. Oh yeah. We just want to make sure. Oh no. What? Okay. This is crazy. So from dynamic takes. So we're setting from dynamic. Even though it's used in. Oh, this is like some crazy recursion, isn't it? Well, not recursion, but we're using it there and we're going to use it there. Let's go down a little. Oh, well, we know what dynamic type is. So we're saying that the A. Oh, excuse me. No. From dynamic, we're saying that this A is going to be an int. So we're cool with that. And then we're going to return an int, which is, shut up, which is there. Here. Go away. I can sort of eliminate that, but I haven't. Cool. So we'd know that that's doing that. And then the second thing it expects is a dynamic, which is what we're going to pass it. But this dynamic is going to be this function, which if you look, it returns a dynamic. Perfect. So let's do that. So pi plus. Oh, amazing. What? How it? No, it can't work it out. It can't simply just work it out by giving it that. No way. Okay, it worked. What the? Oh, that's mental, isn't it? Isn't that mental? How did it work it out? It's because there. It knew. Okay, so it was able. So, oh. But how does it... Hold on. What does asum do? Does it check which ones return nothing? Yes. That's what's going to happen, isn't it? So asum is basically going to grab it's going to return. Oh, it grabs the first just. Okay, thanks. Yeah, that makes sense. So, yeah, because technically it should only pass, only one of these should be a just. Does it have to run through all of them then? I guess it's not very efficient, is it? If you're going to do that. But that's what it's going to have to do, isn't it? Oh, it says it right here. Look, the sum of collection of action generalized concat a sum, and it just returns just world. Yeah, which is the first one, and it ignores the second one. Oh, and this is what's cool. We see it, how it's being used for us. Maybe dynamic to a list of maybe dynamic to a maybe dynamic. Right, we're going to try the bool. See how that takes it. How does it take it? So we want that one. And then we want to set, will I need to do the same thing that I did default? I've got a feeling I might do. But let's try it anyway. True. False. Nah. Okay. Well. That's pretty cool. Oh, it's just for default and num constraint. Okay, that makes sense. And that's pretty impressive in itself. Let's do some horrible magic as well. We're going to... So we want it to return a string, ideally, in this scenario. And then this is going to be... poop. Poop 2. Just poop 2. Hey, that's pretty... Let's be honest, that's pretty impressive, isn't it? I'm not going to test the other way around. We get the gist. Oh, is this doing more? Okay, well, it did what we just have been doing. Actually, let's be honest. Tin Tin Thong, it didn't do the ball, did it? Missed a trick there. Could have done a bit of that. I like it. It's good at getting that. So if you were particularly plucky with this approach, you could embed a fully functional and dynamic type language inside of Haskell. Wow, yeah, if you wanted to. The boilerplate around writing type-dependent patterns matches would amortize down to an 0-to-1 as more of the standard library were implemented. Yeah, I still need to properly understand my big numbers. I don't have a, what do you call it? A degree in computer science. So every time I see that, I kind of ignore it. I'll look it up another day. Is that good or bad? I can't remember. I'm happy doing type level programming, but 0-to-1, whatever. I guess sometimes it means slow, sometimes it means quick, which leaves a lot to be said. As more of the standard library were implemented. Okay, but just so we're on the same page, just because you can, doesn't mean you should. Yeah, definitely. I mean, that in itself, if you're going to have to go through a whole list every time, I assume that's going to get a bit of a, it's got to work these out every time, and then it's only going to return the one that has just. And I guess there might be, well, no, there isn't an inch. Yeah. So that's in itself going to be a little bit slow. Go away. There we go. But, however, there is an interesting philosophical takeaway here. Dynamically typed language are merely strongly typed languages with a single type. Well, now we know. Now we know. Generalized constrained kinded extensions. The definition of hash show and dynamic are nearly identical. Recall, hash show, yes, and that one. Oh, so I guess we're going to say, let's abstract this away somehow. There's a clear pattern here that can be factored out. Here it comes. By being polymorphic over constraint, packed inside by enabling X constraint types, kinds, we are able to be polymorphic over constraints. Oh, we can do a C. I need like a... This is the wrong one. I'm going to make one for... where are we? I'm going to make one for like my brain exploding. I've got this one. Sorry, I did the total wrong thing. I've got this one. Oh, adios, amigos. See you soon, Tintin Tong. Yeah, I guess we're getting quite near the end. No, we're not. Oh my god. No, we're not. Well, I'm getting to the end anyway. There it is. Oh, we're fairly close. Oh, hold on. I'll take this thing away. Yeah, I need one of these with like a brain melt. Like a sort of... maybe I'll make my head explode. Like something like that. I'll do it. I'll see. Okay, so let's write this. Sweet. Yeah, because we've seen this before in the previous chapter. And we can just make has. Which is cool. So then we're using the C. So it's like a function of type to constraint. It's a cat. Where is she? She's just itching. She's itching herself. Where am I? Constraint. Oh. I got sidetracked by the cat. Yes, where... Here, then we can do has, which is going to be of C. Yes. So it's going to be of the constraint C, which takes a T, and that's a type to constraint, okay, which will make more sense in a minute. And that's a T, and has C. Should I try and explain that? I guess I should. Actually, let's not write yet because it makes more sense when you see it being used. Elim has. Elim has. So that's my cat was trying to get out because I just heard my wife going, "You monkey." I don't call my cat a monkey. It's a sod. It's a madam, my cat. It's like a little queen going around trying to rule the bloody house. And never been appreciative of anything apart from being stroked. Which, let's be honest, I don't know if it's giving me any benefit. It's more the cat's getting benefit out of being stroked. Okay, hold on. Sidetracking. I'm able to like talk and type stuff at the same time. I'm multitasking. I'm sure I've been told many a times I can't multitask, but I just did it. Okay, so let's see it in its use. Can we see it in its use? Yes. Can we? Well, I guess we... well, I know that this is obviously a function which expects a t, which is this t here. So we've got a constraint which is going to be to whatever type we give it. So it's going to be there, type to constraint. So that's going to be our constraint. And it's going to be attached to whatever t is. And that will return our constraint has... Oh, has c. Oh, hold on. Yes. It will return that, which is this, which is... So ultimately, this will be a constraint, given whatever you pass it as t. That's what it's saying, isn't it? So in our example, our constraint, so for what type... So if we look at the original implementation, where were they? They were up here. Actually, let's look at them on the right. There they are. So we're trying to make these. We're trying to like make them. We're trying to factor them out ultimately. So if you look, you've got that's going to be of the show constraint, and that's going to be a typable constraint. But here we're trying to make the constraint of t, which is still the same. So we're passing that along, but we're not. You see how we had to write two different types for a typable and for a show, but here we can either pass on the typable or we can pass on a show, and that'll do the same biz. So then we've got an elim has, okay, so which is going to get the value out of has, which is what we already had before, and then we can do type has show. Yes, which is... Oh, hold on. I'd have to... That's cool, isn't it? Except it'll complain because I've already got a type of... Do we write it like that? Yes. And has... I'll probably comment it out. So not... Oh, type able. Yeah, okay. So it's duplicate. So it's actually... Where are they? Has show. There it is. That's one down. And what was the other one? Dynamic. Where's dynamic? Dynamic. There it is. Which is bloody clever, isn't it? Except I've done this wrong. Why? Type to constraint. 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 T to has C. T to has C. Why are you not happy? Oh, hold on. We didn't add something, didn't we? X kind constraint. Oh, yeah, we go. That's what it was. Constraint kinds we want. Why don't you allow me to do it? Come on. Add. Well, it's not that one. Okay, well. We'll do it here. What was it? Constraint kinds. Whoa, hello. Oh, tomorrow's Wednesday, isn't it? Happy? Except we've got 5 errors now. Type able. What's the matter with you? Oh, it needs to import it. Okay, that makes sense. We'll bring it from kind. Yeah. Okay, it's happy now. No, we've still got 2 errors. Where are the 2 errors? Oh, because dynamic is below. Okay, we can lift them up. Let's bring them up. Up the top. Let's bring them up. Let's bring them up. Yeah, now it's going to complain because it's got 2 instances of each. Of all 3. Actually, should I just get rid of that? Rid of that. This is purely to make the... Sweet. What's the matter with you? Import from chapter 7. Don't think so. I'd like to just use that one up there. Thanks. What's the matter with you? You're still not happy. Is it because it's... Oh, okay. Yes. Go away. Do we use elim has show? Oh, it's all going to be implemented differently, isn't it? Go back, abort. Hold on. I'm bringing things back in. Was it from kind? Have I brought it in from the right place? Is it from kind? I can't remember. Let's delete it. I thought it was from kind, but maybe I'm totally wrong. From base, kind, base. I thought it was from kind, but it might be that actually. Extensions. Should we do it from extensions? And then maybe it would be nicer to us. No, it is from kinds. Oh, it is from kinds. I was right. Not extensions. Go back. Kind. Be kind to me. There we go. And I'm going to read those messages, but I'm trying. I can't read 2 things at once, as much as I'd like to. That would be amazing. You also need import type from kind. Yeah. I think it's because... well, we should have an error now. These should say... Which isn't... Yeah, I get another little weird thing. Look, my little rocket here, it does sometimes show there's an error, which clearly means that it's working. See, look, it says 2 of 1, but then here I had a tick, and I haven't got them aligned with each other. Okay, so this is going to be these are not going to be happy, so we're just going to comment them out until they stop not being happy. Where's the other one? There. And this one. And I guess... illegal instance of show. Let's just keep going. Because I guess... this will... I need to just comment everything. I'm getting into a world of pickle commenting things out. Because loads of things... Dynamics here. So, okay, so let's... okay, so let's pop that here. I thought this would work, but I'm going to go back to step 1. Why didn't you work? There's nothing above there, apart from any, but we don't care about any because that's not used anywhere else. We'll pop that here. Obviously, you're going to want a limb. Okay, so which lives there, which again, that needs to be below. We can uncomment that. We can do this. We can then do that. Yep. And then it's not happy about dynamic. But I guess dynamic... not in scope. Oh. So what? It doesn't need to be an A anymore then, does it? No. Hold on. I thought we were doing exactly so. That's the idea. Has show. And has typable, which was dynamic. But here it's saying not in scope. No? What's that one then? What do you mean you're not in scope? I can see you. I think you're lying to me. So I'm going to restart you. No, you're not. Oh, ooh. Here's type. Isn't dynamic just a synonym? Oh! So it should just be like that, shouldn't it? Is that what you're saying? No, it's not like that. Oh, so it's just... oh, of course. Import. Well, no, it's all made in, there's no imports in this file at all. It's all from within. It should be done. I mean, why we've got like this? That makes no sense. Yeah, of course. Yeah, that's what I thought, but should it? Oh, is that what it was? Yes, of course, because that's its constructor. Oh, goodness. Yes. Sorry. Yeah. No, I was totally reading it. I for some reason in my brain, what I was trying to replace here was actually part of the type. So I was just I kept trying to put dynamic. It's friggin' dynamic. But obviously, because before it was type dynamic equals dynamic, blah, blah, blah. So the constraint was named the same as the declaration. Caught me out. My fault. My bad. Where are we? So, PyPlus. We've done a PyPlus. Everything is compiling, which is good. We've got rid of all that stuff above. We've just extended the ability to have a has. Oh, I need to press play. There we go. Music went. Yeah, so we can have a has show in a dynamic because we've given it the ability to have us, to pass this show along and make that magic. Sweet. And then we're doing something we want to be able to talk about multiple constraints at once. Oh, like the function which determines if its arguments is empty. Is mempty. Okay. Isn't that... Oh no, is mempty? Is that a function that already exists? I know is empty is one, but I think... I don't know. So we want a monoid, A, an EQ of A, and that's going to be A to bool. So is mempty, there it is. A is equal, A equals, oh, okay. Maybe we'd like to construct an has around this constraint modeled A. Oh, EQA. Unfortunately, there's no type level lambda syntax, so we're unable to turn this type into something that's curryable. We can try a type synonym. Oh, hello. Let's try that. Monoid. Oh, and EQ. A. Whoa, I need an A obviously because they both take A. Yeah, and then that's going to be a... But that's not going to interact the same, surely. I don't think this is going to work, but I could be wrong. Okay. What are we doing? But GHC won't allow us to construct a has, monoid, and EQ. Yeah, I was going to say that doesn't make... Yeah, that doesn't make sense. The type of... Yeah, so if we try and say... So a list of true, and we want to say that it's actually a monoid A or an EQA, and that being our A, then yeah, it's going to complain. Should we test it out to make sure? Why not? Gonna reload. I can't remember if you lose all your imports, but whatever. So we get a different error. The type synonym should have one argument but has been given none. Is that the same? Oh yeah, it is the same. In an expression, type signature has monoid and EQ. In the expression, has true, has monoid and EQ. Yep, okay. Should have one argument but it's been given none. Yeah, that makes sense. Okay. The problem is that type synonyms must always be fully saturated. We're unable to talk about monoid and EQ in its unsaturated form. Only monoid and EQ A is acceptable to the compiler. Yeah. So you're not able to keep both of those around for the A. Okay. Yeah, fortunately, there is a solution. Of course, there's a bloody solution, isn't there? A class. Where are we? Fortunately, there's a solution for constraint synonyms. Though not the type synonym in general, we can instead define a new class with a superclass constraint. Sounds like we're super class. And an instance that it comes for free given those same constraints. So class, blah blah blah, blah blah blah. So should we do it? Let's do it. Class monoid A and EQ A. That's type constraints, and we'll call that monoid EQ of A, and then we make an instance. Oh, this is clever. What's going on here? We've got to do it twice. Okay. Oh, yeah. I'm going to... Typing is starting to go out the window. Monoid EQ A. That's basically what we've done, except shall we get rid of that one? No, we still need it. Do we? What? Hold on, no, this is like get rid. Okay, go to the bottom. Don't do that. Let's refresh this. We're getting there. This is known as a constraint synonym, while type synonyms are unable to... Okay, well, I spelt this wrong, haven't I? No, I haven't. Monoid EQA. Monoid. Do I still need the other one? No, because that's something entirely different. Oh, flexible instances. Okay. No, it's not that then. Was there something you need to add? Solution for constraint synonyms. They are definitely the same. Okay, what the hell did I have wrong then? Hold on. I want to see where my typo was, if I did have one. No, there's still an error. Add undecidable instances. Let's keep going. Yeah, that's fine. Doesn't tell us that though. So what did it? Undecidable instances. Okay. Thanks, Haskell language server. You saved my skin yet again. This is known as a constraint synonym. While synonyms are unable to partially applied, classes have no such restrictions. Well, they seem they do, because I had to create a flag. But anyway. Let foo equals has true of has monoid EQ. Elim has is mempty foo false. Let's do it. I've got to reload first, haven't I? So we'll reload. We'll do that, and then we're in elim has is mempty, and we'll pass foo false. Cool. So that's worked. And scoping information with extensions. How long? What? I think I might. Yeah, I'm going to leave it for today. I was aiming for a chapter per session, but my brain's hurting. But we know at 7.2, so I can type that in. Hold on, I've got another load here, haven't I? Here we go. Let's do some of these. Oh, that looks nice. Let's do it like that. And we're at 7. Oh, hold on. I can embed it in here. Look. 7.2. Except I've put 3. 3 for the lols. 32. 7.2. There. That's where we're up to. Yeah, I think that's a good place. Scoping information with extensions. Yeah, I think that'll do. And then we'll look at this stuff. This is not too far to go. I guess we're now looking at the ST. Okay. And stref and blah, blah, blah. Run st. I think this is the context that I've seen it in, to be fair. And then we're in roles. Yeah, then we're in roles. Wow. Yeah, there's definitely a bit too much for me to carry on because it's like 9 o'clock. I don't know what time I started. 6:30. So that's 2.5 hours. Plenty. That'll do. That'll do. Well, thank you for joining, whoever's left, if anyone. And yeah, hopefully, I don't know. I can't guarantee a day again. Sorry. I'm going back to my unguaranteed times. But I will upload the past ones. Let's have a look to my... I'm a few behind from memory. So look at YouTube. Let's have a look at my channel. Videos. What am I up to here? So I'm on part 9. Learning. Okay, so I'm still part 4, and I think today's part 6 of Thinking with Types. So look, playlists. Yeah. So that's only got 4 videos. I'm pretty sure this is the 6th one. Like that. How can we... I don't want you to play though. There we go. Let's look at the videos. Videos? It's not this one. Let's make this a little bit bigger. We can just click there, can't we? Here we go. Videos. What are we up to? Thinking with Types. 6. Yes, we're on 4. And this is Thinking with Types 7. So I'm a few behind. Yeah, I'm going to upload those. And upload part 10. Let's have a look. Part 10. Yeah. And what I might do is maybe the next one I'll do some Learn Haskell again. I'll go back to basics. Because I've kind of like, look, I'll be doing 3 of those in a row. And if you look, I try and sort of not do too many of one. Because otherwise it will just freak people out if I just keep doing difficult stuff. And I also want to be teaching. So that'd be cool. Yeah. Okay. Well, that's that for today. I'm going to maybe do some editing. I've noticed something though. My laptop's not as noisy as normal, so maybe, hopefully, if I watch the stream back and there's no random errors, we should be good. Oh, hold on. How do I don't know how I share stuff. Home? Look at it. What is this? Feature view as subs. I wish. See, this is a good thing about Twitch. At least you can give, you know, look, cmdv-tv, which is fine. YouTube, thanks. What's that? Bloody rubbish. But anyway, on that note, I'll do a bit of this. Some of that. There we go. Makes me feel better. And then the other one I'm going to do is say goodbye. And see y'alls next time. See ya.